Okay, in the last lecture I showed you several formulas for different derivatives, two of which were that the derivative of sine is cosine and the derivative of cosine is negative sine. I want to prove those two for you today. And we will also then do tangent, secant, cosecant, and cotangent. Okay? Now, the calculus here is very simple. But before we can do the calculus, we have to do a bit of geometry. That's where most of the work comes into play. All right? I need to show you the limit of sine of theta over theta as theta goes to 0 equals 1. I need to show you that because we have to use that. Okay? So look at the picture that's here. We have a circle with a center of O and a radius of 1. Okay? And then we got all those points, A, B, C, D, and E drawn in certain places. You can look at the picture and you can see there, and there's several of those angles are right angles. Okay? This angle right here is the angle theta. Okay? All right. So here's what we're going to do. And theta, by the way, in this case is being measured in radians. Okay, now, one second here. That color's not going to show up really well. Okay. All right, I want you to look at this arc right there. The arc of the circle from A to B. If you know about radians, then you probably know that the arc of that circle is equal to the size of this angle times the radius of the circle. So the arc from A to B has a length of theta times 1. So in other words, theta is the same as the length of the arc from A to B. Okay? Let me fix those. Those are really messy. That's a 1 right there, and this is a theta. Okay. All right. Now, okay, I'm going to leave that arc colored green because if I try to erase it, the whole circle is going to disappear. Okay. Now what I want you to do, let's use a different color here. We'll use blue. I want you to look at these two lines. Line segments, I should say, from A to E, and then from E to B. Okay? So those are connecting A and B, right? But the path that you travel is longer than if you walked along the circle from A to B. So that blue path takes you from A to B, but it is longer than the green path. So the arc from A to B is shorter than the line segment from A to E plus the line segment from E to B. Do you agree with that? Okay, and now the next thing I want you to look at, I'll make this one yellow. So I want you to look at this line segment from E to D. Okay? Do you agree that that is longer than the segment from E to B? If you were standing at E, let's say there was two of you, both standing at E, and I send one of you over to point B and the other one over to point D. The person going to D has to walk further, don't they? And do you know the reason why? Because this is a right triangle right up there. And EB is a leg, and ED is the hypotenuse. And the hypotenuse of a right triangle is always longer than a leg. Okay? So ED is longer than EB. So here's what I'm going to do. Right here, that EB right there, I'm going to replace that with ED, and it will get bigger because I'm replacing it with something bigger. Okay? All right, now, look at what I left off with. Line segment AE plus line segment ED. Well, look, they're collinear, right? Segment AE plus segment ED, just put them together and I get one line segment AD, right? Okay. Let's make that purple. It looks like purple and red. That's because the purple is mixing with the yellow there, and it's making it look red. Okay. All right. Next step. That line segment AD has a length that is equal to the tangent of theta. Do you know where I'm getting that from? It's because of this. Right here, from O to A, that's a radius of the circle, isn't it? So that has a length of 1. Okay? And look where angle theta is. And you know that in a right triangle, where theta is one of the acute angles, the tangent of theta equals opposite over adjacent. So, tangent of theta equals AD over OA, but the length of OA is 1 because I said that that circle has a radius of 1, so that equals the length of AD over 1, which is just the length of AD. So in other words, where we left off there, where I had segment AD, the length of that is just equal to the tangent of theta. And of course, tangent equals sine over cosine, right? Okay, good. So now, look at this. What's that telling me? That says theta is less than sine of theta over cosine theta. Theta is less than sine of theta over cosine of theta. which means cosine of theta is less than sine of theta over theta. Correct? Okay, now we're going to leave that just like it is for a minute. Now what we're going to do is we're going to look at those triangles that are drawn inside the circle. Okay? And what I want you to do is I want you to look at, let's see, I'm running out of colors here. Let's do, we'll make this lavender. I want you to look at this line segment BC. Okay? All right. In this triangle right here, it's a right triangle, and BC is one of the legs, and the hypotenuse is 1. And I can say, one second. Okay, I can say sine of theta equals, what is sine? Opposite over hypotenuse. Okay, but the length of OB is 1. So there, look at that. The length of that lavender segment BC is exactly equal to sine of theta. Sine of theta is equal to the length of BC. Okay? Now look at the straight line segment from A to B. Let's make that sort of a reddish color here. And look at this triangle right here. That's a right triangle. And BC is a leg. And AB is the hypotenuse. And the hypotenuse is always longer than the leg. So AB is longer than BC. And also, that line segment from A to B is shorter than the arc, which is highlighted in green, from A to B. You see that? If you're going from A to B and you walk along the red, which is a straight line, that's going to be shorter than walking along the green, which is a part of a circle. So I'm going to write down that line segment AB is less than arc AB. And do you remember how long arc AB is? We wrote that down at the beginning right there. The length of that arc is equal to theta. So the sine of theta is less than theta. Which means sine of theta divided by theta is less than 1. We're going to go over here and let's add that on there. Okay, that's the geometry that we had to do. Now I'm going to take that thing that I circled in red. Sine of theta over theta is greater than cosine theta and less than 1. And we're going to do a tiny bit of calculus on that. We are going to do the limit as theta goes to 0. Now all of that geometry that we did there, this is important. Theta is a positive angle. And that's important because there were some inequalities and I divided both sides by theta and the inequalities did not change directions, and that's because theta is a positive angle. So what I'm going to do here is I'm going to do the limit, whoops, this should be black, of sine of theta over theta as theta goes to 0, but theta is positive. So that'll be theta approaches 0 from the positive direction. Okay, now that is less than or equal to the limit of 1. And greater than or equal to the limit of cosine. What theorem am I using here? I'm using what was called the Squeeze Theorem. Because sine of theta over theta is between cosine theta and 1, then the limit of sine of theta over theta will be between the limit of cosine theta and the limit of 1. And if those two lavender limits equal each other, then the purple limit in the middle has to equal that same thing. Okay? So let's look at the two limits on the outside. Okay, this one over here should be obvious to you that that's 1. The limit of 1 is 1. Okay, now how about this limit over here? This all boils down to how well you know your trig. Okay, cosine of theta. As theta approaches 0 from the right hand side, what will cosine of theta approach? The answer is 1. Okay? So that tells us that the limit of sine of theta over theta as theta approaches 0 from the right. Oh, by the way, I'm sorry. Those inequalities that I wrote there, when you put a limit onto it, they should now be greater than or equal to, less than or equal to. Okay? So now we have the limit of sine of theta over theta as theta approaches 0 from the right. It's greater than or equal to 1 and less than or equal to 1, which means that it equals 1. Okay? Now what about the limit as theta approaches 0 from the left? Okay, so the trick here is to notice that sine of theta over theta is what's called an even function. Do you remember that from pre-calculus or college algebra? Sine is an odd function, and theta is an odd function, and an odd function divided by an odd function is an even function, which means when you plug in a negative number, you will get the same value as if you had plugged in its positive counterpart. So if positive numbers approaching 0 give us a limit of 1, then negative numbers approaching 0 will also give us a limit of 1. And since the limit as theta approaches 0 from both sides is 1, then that means the limit is 1. Okay, I know that took a little while, but that's what we needed to help us find the derivative of sine. So all of this stuff we did up here was just to figure out that limit that I put in the red box. So we don't need any of that geometry stuff anymore. So I'm going to move that off of the top of the screen, and we will need that limit in the red box. We'll need that in just a few minutes. Okay, there's a second limit that we're going to need. We're going to need to figure out the limit of cosine of theta, whoops, I forgot the S, minus 1 over theta as theta approaches 0. This one will be a lot easier. There's no geometry involved. We just got to use some trig and some algebra, that's all. Okay, here's what I'm going to do. I'm going to multiply that times the number 1. But I'm going to write the number 1 in a very particular way. I'm going to write it as cosine of theta plus 1 over itself. Now let's do that multiplication. And what do we get? On the top, we'll get cosine of theta squared minus 1. And on the bottom, we get theta times cosine of theta plus 1. Okay? Now, do you recognize the top? That is negative sine squared, because cosine squared plus sine squared equals 1. So 1 minus cosine squared equals sine squared, which means cosine squared minus 1 equals negative sine squared. Okay, now I'm going to take that negative that's on the top, and I'm going to factor it out in front. And then I'm going to take that fraction, sine squared theta over theta times cosine theta plus 1. And I'm going to break that up into two fractions. I'm going to write sine theta over theta times sine theta over cosine theta plus 1. And now these limits are both very easy. Okay, let's do this. Okay, what do we get? So we get negative. This guy right here we just figured out a few minutes ago. And now I know that that limit's 1. And this limit is simple. That's going to equal 0 over 1 plus 1. So what do I end up with here? Negative 1 times 0, which is 0. So this limit equals 0. Let's write that down and put a box around that also. Okay, those two are going to be very important. And now finally, we can find the derivative of sine. There will be nothing difficult about this now. We've done the hard part. Okay, so let's write sine prime of theta, or we can use x if you prefer. Okay, so what's that going to equal? It equals the limit as h goes to 0 of sine of x plus h minus sine of x over h. Now there's a trig identity for that, sine of x plus h. Okay, we know what that equals. That equals sine of x times cosine of h plus cosine of x times sine of h. Okay, and then we have also on top a minus sine of x. And then on bottom is an h. Okay, I can split that big fraction up into a sum sine of x cosine h minus sine of x over h plus cosine of x sine of h over h. And notice in that first one, I can factor a sine of x out. Let's write it like this. Okay, let's write sine of x times the fraction cosine of h minus 1 over h, and then plus, and the second one, let's write cosine of x times the fraction sine of h over h. All right, this should look good. Look at this. That sine of x does not have an h in it, so it has nothing to do with the limit. So I can write this. And then we can write plus cosine of x times this limit and those are exactly the two limits that we figured out. If you don't remember what they are, look in the red box at the top of the screen. We have here sine of x times what? Times 0 plus cosine of x times what? Times 1. And what's that going to equal? Cosine of x. So the derivative of sine equals cosine. Okay? That's where that comes from. Let's make a chart here. The derivative of sine equals cosine. Okay, and now we can also do the derivative of cosine, and it's going to be very easy. It's going to be very, very similar. Okay, right, cosine prime of x equals the limit as h goes to 0 of cosine of x plus h minus cosine of x over h. and that equals the limit as h goes to 0 of cosine x cosine h minus sine x sine h, and then minus cosine x, and that is over h. And very similar to when we were doing sine, you see I can break this up into cosine of x times the limit of cosine of h minus 1 over h minus, this time, sine of x times the limit of sine of h over h. And that's going to give us cosine of x times 0 minus sine of x times 1, and that equals negative sine of x. Okay? So the derivative of cosine is negative sine. You need to commit those to memory. And now it should be easy for us to find the derivative of tangent. And the derivative of cosecant. And the derivative of secant. And the derivative of cotangent. These will all be really easy. All we need are these two and the quotient rule from the previous lecture. Okay, so let's find the derivative of tangent. I'm just going to write tangent prime. Okay. That equals the derivative of sine over cosine. Use the quotient rule. Do you remember? It's the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. That's the quotient rule. Okay, I'll say it again. The derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. What is sine prime? Sine prime is cosine. So sine prime times cosine is cosine squared. What is cosine prime? It's negative sine. So I have negative sine times negative sine, which is plus sine squared. And that is over cosine squared. Now, what's cosine squared plus sine squared? It equals 1, right? So there's the derivative of tangent. And I would encourage you to memorize it not as 1 over cosine squared, but as secant squared. You're going to need to know that one. All three of those you're going to need to have memorized, okay? All right, let's do cosecant. It's not that different. Cosecant is 1 over sine. Okay, so again, we're going to have derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. Okay, so derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. So what do we have there? We have negative cosine x over sine squared x. That's the derivative of cosecant. And I would encourage you to memorize it like this. I would write negative cosecant times cotangent. That's the derivative of cosecant. Okay? Let's do the derivative of secant. Well, that just requires me to only change the sign on the bottom to a cosine. So that's just going to change a few of these things here. So we will have the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. So we have sine of x over cosine squared x. And I would encourage you to write that like this. Secant x times tangent x. That's the derivative of secant. Okay, and one more and then we'll be done. The derivative of cotangent. That's also just needing the quotient rule. Cotangent is cosine over sine. Okay, so derivative of top times the bottom minus the top times the derivative of the bottom over the bottom squared. So that's negative sine squared x minus cosine squared x over sine squared x, which equals negative 1 over sine squared, which equals negative cosecant squared. All right, there you go. all 6 trig functions. You now know their derivatives. Let's see. Now, let me forewarn you. This one and this one, you have to know by heart so well that you will say them without even thinking about it. Okay? If you don't know those, I just don't see how you would end up passing this class. This one and this one do come up more often than you would think, especially in Calculus 2. So you're going to need to have those memorized as well. But you might have to think about them for a second to remember them. That's fine. But the derivative of sine and cosine you should know so well that they will come out of your mouth before you even think about it. Okay? Or at least close to that. That's the goal. All right. That's all for today.